Hello everyone and welcome back to the channel. We have talked about message queues as incredible tools for asynchronous processing and building resilient systems. But what happens when a message for some reason just can't be processed? What if it's malformed, or the consumer has a bug, or an external service is down? If not handled correctly, these failed messages can get stuck in endless retry blocks, block your main queues, or even get lost forever. This is where the dead letter queue, or DLQ, comes in. It's the essential safety net for your asynchronous processing. In system design reviews, discussing dead letter queues isn't just a good idea, it's a mark of truly robust design. Today we are diving into their critical role. Okay. So first let's try to understand the problem. What challenges does a dead letter queue specially address in a system, in a message queue system? So let's just have a small message queue system. We have here a producer. Here we have our message queues, and we have here our consumers, C1 and C2. The producer sends the message to the message queue, and the consumer get those messages or events or pull them. Let's assume first the consumer is failing. So let's say that a consumer might fail to process a message due to like a temporary network glitch, a bug in the code, or invalid message data. If the message broker, which this is the message broker, if the message broker simply re-queue it, the consumer might pick it again, fail again, and enter an infinite retry loop. This wastes resources, delays other messages, and effectively blocks your main processing pipeline. Number two, we have lost messages. Without a mechanism to handle persistent failures, messages that constantly fail might eventually be discarded by the broker after a certain number of retries, leading to a silent data loss. Number three, we have a debugging nightmare. When messages fails, it's incredibly difficult to track which message failed, why they failed, and whether they got lost. This makes diagnosing and fixing bugs a huge challenge. And number four, poison pills. A particularly nasty type of failed messages is a poison pill. A message that, due to its content or format, constantly cause a consumer to crash or fail processing. Without a dead letter queue, such a message can repeatedly bring down consumers and halt processing on the main queue. Okay, so what is a dead letter queue? Let's have our example again. We have our producer, we have our message broker here, and we have our consumers that picks the messages from the message broker. A dead letter queue is a special designed message queue that is designed to hold messages that cannot be processed or delivered after a specific number of retries or attempts. So we have here our dead letter queue, DLQ, and basically it will pick all the failed event or all the failed messages. So again, a dead letter queue is a special designed message queue that is designed to hold messages that could not be successfully processed or developed or delivered after a specific number of retries or attempts. Think of a dead letter queue as a quarantine zone or a holding pen for problematic messages. Instead of discarding them or letting them endlessly cycle, these messages are moved to the dead letter queue. Okay, so let's look in details. How does this work? So let's try to go in a normal flow. So our producer will send a message to the main queue, and this is the main queue. Okay. So it will send the message, and this is the message here. We have a message here, and and after that, a consumer will pull the message and attempts to process it. So let's say that we have a consumer here. It will pull this message and try to attempt to process it. But the message fails. Like the consumer fails to process this message. The message broker, which this one, let's call it MB. This is a message broker. The message broker, as configured, will typically requeue this message. This one was failed. Will requeue it again. It will requeue back into the main queue for a certain number of retries, often with increasing delay between retries. Let's say that 10 retries. So after a configurable number of retries, let's say that 10 attempts, if the message still fails to be processed successfully, the message broker automatically moves the message from the main queue to the dead letter queue. So here we have our a dead letter queue, DLQ, and when the message fails after more than 10 times, it will be moved directly to the dead letter queue. Okay? The dead letter queue here, like the message in the dead letter queue, typically contain not only the original message payload, but also valuable metadata about its failure. For example, the error message, the number of retries it underwent, and the timestamp it entered the dead letter queue. And after that, we have what we call a manual intervention. Like messages in the dead letter queue are crucially because they are not automatically reprocessed. They sit they're waiting for human intervention. Operates for developers, operators or developers that can then, for example, investigate and debug, maybe discard or maybe manual repair and replay. So why dead letter queue is quite important in system design? There are several reasons. We're talking about 6 in this section. The first thing, robustness and reliability. They are your system's safety net. Dead letter queues prevents messages from being lost or stuck in infinite retry loops, ensuring the overall stability and reliability of your asynchronous processing pipeline. Number 2, error isolation. They isolate poison pill messages, messages that constantly cause failures, from your main processing flow. This prevents a single bad message from blocking or crashing your entire consumer. Number 3, debugging and analysis. And the letter queue provides a centralized, dedicated location to inspect failed messages. This is incredibly valuable for diagnosing and fixing underlying bugs, understanding unexpected message formats, or identifying issues with external dependencies. Next, we have operational visibility. Monitoring the depth of your dead letter queue gives you immediate insights into recurring issue or unexpected failure rates in your system. Next, we have data loss prevention. Like most importantly, dead letter queues prevent critical data from being implicitly discarded due to transient or even a paramount processing errors. You return the message payload for later recovery. And lastly, interview focus. This one, bringing up a dead letter queue demonstrates that you think about failure models or failure modes, error handling, and operational concerns. Qualities of a strong system designer. Let's talk about some key considerations of dead letter queues. Like when designing dead letter queues, we need to keep some things in mind. The first thing is the retry policy. Like carefully we define the number of retries and the delay between them before moving a message to the dead letter queue. Also, we need to talk about the dead letter queue retention. Like how long should message be kept in the dead letter queue before they are permanently purged. This depends on your business auditing or recovery needs. Number 3, alerting. Set up immediate alerts when messages land in the dead letter queue, so operations teams can investigate quickly. Next, we have monitoring. Regularly monitor the depth of and throughput of your dead letter queues. Lastly, replay mechanism. Plan how you will reprocess messages from dead letter queue once the underlying issues are fixed. Okay, so how to discuss it in the interviews? I would say in system design interviews, introduce dead letter queues whenever you propose message queues or asynchronous processing for critical flow. Explain why it's needed, I would say, to handle, for example, failed messages, poison pills, and prevent data loss. Emphasize its role in debugging and ensuring operational reliability. This show a foresight and a mature approach to design fault-tolerant systems. So yeah, Thanks for watching, and yeah, see you in the future, guys.